Today we're talking about two topics, one of which is the most commonly missed questions on the final. All right, so here is a commonly missed question. This is not a normal multiple choice where you just pick A, B, C, or D. Each of these is either A or B or C or D. So the top one there, f of 3x. Don't say it. Figure out what you think it is and then write the letter on your iPad screen. I'm hoping the first thing you notice is that it's on the inside, and the inside stuff is left-right stuff. Is that like horizontal or is that like vertical then? Horizontal, good. So it's either horizontal shrink or horizontal stretch. And now, you got to ask yourself, that 3, what does that make you think it should do? Shouldn't it be 3 times wider? But it's not, because it's the opposite, because it's on the inside, and therefore it is a horizontal shrink. B is in boisterous. Raise your hand if you had it right. Okay, good. Next one. Get the next. Now that you got the idea, get the next 3. See what order these should be. It's like B, D, A, C, or whatever. Figure it out. All right, I heard somebody say the wrong answer, so I won't call on that person. Let's try NS in the back corner. What do you think it is? Yep. Okay, so what letter is that? All right, good. So C, that's vertical because it's on the outside. Stretch, because you can trust the stuff on the outside. It looks like it's 3 times taller, and it is. All right, and what do you think is next? D or A? How many say A? How many say D? Almost everybody says D. All right, horizontal, it's on the inside, so it has to be horizontal. We already used the other one up, so it makes sense. And then the last one, by process of elimination, is A, but let's double check it. Vertical shrink, it's on the outside, so it's vertical. Shrink because it's a number smaller than 1. Very good. Who had it perfect from the beginning? All right, good. Moving on. Write an equation. These are kind of tricky. Let's start with A. That's not too tricky. It's just a square root that's been moved down and to the left. So your equation, write it, y equals square root of, and then figure out what to do. It's a good question. The test for higher algebra, I believe, is all multiple choice. So this one would probably be like a matching sort of a deal. So it's still multiple choice, but it's, matching is kind of just a version of multiple choice. All right, so you got a square root of and you got an x. And then the whole thing's been moved. We're looking at this one right here. The whole thing's been moved to the left 3 spots. That means plus 3 or minus 3? Plus 3 is correct. And then the whole thing's been moved down 4. What do I do for that? Minus 4 on the outside. Raise your hand if you had it right. Okay, good. Number B, or part B, is significantly harder because it's been stretched and flipped in a weird way and stuff. So try B. And I'll figure that if you got B right, we can move on because C is really easy and D is really easy too. All right, hopefully remembering that it's absolute value, because if you can't then do that, then you have nowhere to go. All right, it's absolute value. What do you think?
Negative absolute value.
Okay, you think negative on the outside. Now, why do you think negative on the outside? Because it's an up-down flip. It used to be a normal V, and now it's an upside-down V. I agree with you. Then let's get a different person to tell me more. In the back corner, Gandalf. Where's the 1/2 going to go, on the outside or the inside? He thinks the inside. And then, do you think I should put parentheses or not? What do you think? Come on, take a shot at it. You think no parentheses, okay, and then what do you think is next? X plus 3, okay. Now, here is my question. Would you agree that the answer would be different if I put parentheses on here? It would cause a different number to come up. Because in the one case, I'd multiply the 1/2 only by the x, and in this case, I'd multiply it by both of them. So therefore, it's obviously different. So which one do you think it is? Do you think it says parentheses or not? All right, well, you're all wrong. It needs parentheses. Okay, whenever you do a stretch on the inside or a shrink on the inside, you need parentheses. So get used to it. Here's why. It's a lie. It's not a lie. Let me show you why. Do you get that if you start on the inside here, that you have to, if you're going to do these things, you have to do them in the opposite of normal order of operation? Okay, so if I were to have parentheses here, that puts this as the normal thing you would do first. So we don't do things in the normal order. So if it has parentheses, we'd have to start with that. Whereas if it doesn't have parentheses, then the multiply would have been the normal thing to do first, and we should have done that first. So it's going to even change the order that you do it in if you have parentheses or not. All right. And then again, the last thing, to just clarify it, if I write it like this, and then the last thing we have to do, by the way, is to move the whole thing up 1. So I'm going to put +1 there. There's my final answer. If I had not had parentheses, do you get how that is going to be different than this, and only one of the two can be right? If they're going to be different, then only one of them is right. Okay, so if you actually used a calculator and checked it and typed them both into the calculator, you could see one of them would be where we would expect it to be, and one of them would not be. The key, of course, is this number right here. When I write it like that, you can see with parentheses in it that it's clearly moved to the left 3. This one, it's not moved to the left 3. If you factor out the 1/2 and put it like it's supposed to be, this would end up being x plus, and then to get that to be a 3, we'd have to have a 6 over 1/2 times 6 over 2 is the same thing as 3. Plus 6, there we go, thank you. And that one was moved to the left 6. This one, if you graph it, will only be moved to the left 3, which is what we want. Okay, the last thought here is, question? Yes, that's exactly what I was just going to say. If you wanted to, you could put the 1/2 on the outside. And then you have to deal with this whole do we have parentheses or not thing. Let me show you why. Okay. Okay, we're zooming in on B here, so I'm going to get rid of this one. And I'm going to rewrite the first one because it got so messy. We said it was y equals negative on the outside, parentheses, 1/2, and then x plus, it's 3 to the left, there we go, and then up 1 plus 1. Okay, there's what we said the first time. Here's another option. And why will both of them work? It really boils down to that putting a 1/2 on the inside or 1/2 on the outside does the same thing. Think about it. What if it was as simple as x? Do you get how if I have the absolute value of x and I put in the number like 8? If I put a 1/2 here, isn't it going to cut the 8 in half and I'll get 4? What if I put the 1/2 in here? Won't it do the exact same thing? You get what I'm saying? So on these absolute value ones, you could have had two different answers. You could put the 1/2 on the inside or the outside. It'll give you the same thing. Another way to think of it, we're zooming in on this green one right here. Do you get how that sort of looks squished compared to a normal V shape? But couldn't you think of that also as grabbing the sides and stretching it outwards? So squishing it or stretching it outwards kind of has the same effect. All right, so Yes, you can write this two different ways, but it is a multiple choice test. So if they had this on the chest, you could say, yeah, that's it. If they had that as a different answer, you could have said, yes, that's it. If they had had both of them, then you should come up to me and say, which one should I pick? Because that's a flaw in the test. You wouldn't want to have two right answers. On this test, you can't pick multiple answers. It's either A or B or C or D. We're not going to have like A and D. Okay? All right. Okay, so that's an important one to talk about because it was missed. It was one of the top 10 missed things on the final last year. So
We don't want to write any equation.
you're going to be, it's multiple choice. So you get to pick. All right, moving on. This one, I can see why a lot of people missed it because they do half and square in decimals and then you get yourself all screwed up. I'd recommend you use a fraction and then this is as easy as pie. Don't say it. Write down the first one, what you think it is. Use a fraction and it'll be easy. All right, so what's half of 9? Use a fraction. 9 over 2. You get how half of 9 is like this? But it's not just half of it, it's half and then squared, and so what's the right answer? That's it. It's half and then squared. Get that? All right, how about the next one? Half of 3. Come on, don't say 1.5. What is it? 3 over 2. And then squared, which makes... There we go. Okay, good enough. Moving on. What are the roots of this? Well, the really common mistake here is kids picked out this. That's not the roots. What is that? That's the vertex. I mean, I can get where a kid sees, oh, that's important. Yeah, it's important. It's the vertex. But the vertex aren't the roots. All right, so if the vertex is over here, if I make a quick sketch of this thing, the vertex is at -3, comma 2. It's right there. Do you get that this is a parabola? Do you get that it's going up like a big U? Do you get that it's never going to touch? And do you get that that means it doesn't have real roots? Ah. So graphing it would be kind of pointless. You can't find the roots by doing that. And you can't factor it either. And so, quadratic formula. You have to use quadratic formula. Don't even bother with the calculator because it's going to have a square root in the answer. And it's got a square root of a negative, which is why it's imaginary, right? So you're going to not be able to do it in the calculator. It's probably on the part of the test that's non-calculator anyway. So there's two parts to the test, calculator and not calculator. So on your iPad, would you please use the quadratic formula to figure out this? Well, you might be saying, what the heck are A, B, and C? How do you get them? Generally, you just multiply it out. Very good. Go ahead, multiply this puppy out. Once you got it multiplied out, you'll know A, B, and C. Then stick them in the quadratic formula. And then your answer is going to be something like this. 8 plus or minus the square root of 2 and an I there over 6 or whatever, but that's not it. It'll be like that. Okay? So multiply it out. While you're doing this part, I'll explain something about what we're going to do for homework over the next couple days. Today, of course, is our last normal day. And then we got finals for the next 3 days. You guys are my hour 2 class, so we have the final tomorrow. Your assignment is to finish the packet. It's pretty simple. You might ask, why are we not correcting homework today or tomorrow? It's just a practical thing that I can't put in one more assignment in the grade book because there'll be kids that are absent. It gets really messy, and then I either give them zeros or whatever, and it gets messy. So I'm not going to put it in, but I am going to collect the packet. How would I use it? At the end of the semester, the teacher has what's called teacher discretion on your grade. And if there's a kid who just misses the grade above them by like 0.4% or something really small, then I sometimes will give that kid a bump, and sometimes I don't. How do I decide? I decide based on not how much I like you. I decide based on how hard the kid worked. That's the main thing I decide by. And how can I tell that? Well, I look back over the grade book. If I see a lot of zeros in homework, they weren't working hard. All the answers are posted, for Pete's sakes. So there should be a lot of really good scores on homework. And then, how about this final review packet? Does that show effort? Yes, it does. Okay, so if you expect to do well in this final, you do the packet, because you just should in the first place. And then the second reason that you should do it is because I will use that as a final determination if you deserve a bump or not. And it's not like I pick for every kid, bump or not. It's I look at the grades and see who's really close. And then usually, you'd be surprised, in a class of like 30, there's usually like 5 or 6 kids that it's right on that edge where they either get the bump or they don't. And usually, about half of them get it, half of them don't. Does that mean if you have one late assignment that you're doomed? No. Because I figured any kid can have one bad day, but it's a pattern. It's a pattern of lots of missing assignments, or like not doing your final review packet would really be really stupid because I've given you this whole speech here too. So, okay, moving on. When you multiplied this out, you should have said x plus 3 plus 2, x squared plus 6x plus 9 plus 2, and the 9 plus 2 goes together, makes 11. And then that's the reason we can't just factor it is because it doesn't factor. If it factored, I would, but I can't, so I won't. So instead, I'm going to put that in the quadratic formula. Opposite of b, I'm going to start saying that instead of negative b. Opposite of b plus or minus the square root of b squared minus 4, and I always put these as parentheses because it's too much to try to do in my head. All over 2a, and a is 1, so it's just 2. And if a is 1, I can put 1 there. And then the c is 11, and that's why we couldn't get an answer, because this part's going to make the answer under the square root negative. Specifically, what was the square root of what? Negative 8. Good. So it's negative 6 plus or minus the square root of negative 8 all over 2. That might even be one of the answers, and I bet a lot of people would fall into the trap of saying, oh, that's what I have on my paper, and it's right there as A, and then they mark it, and it's wrong. Why? Because you can simplify it, okay. And a lot of people think you can just cancel this and this. You can't. Instead, you can do this, though. This is the square root of 4 times the square root of 2 times the square root of negative 1. That's what you break up negative 8 into. It may seem crazy, but it's because that's 2 and that's I. And so my final answer is negative 6 plus or minus 2I root 2 all over 2. And then I realize that's not my final answer. Because I can cancel. 2 goes in there 3 times. 2 goes in there once. 2 goes in there once. And the dividing by 1 is kind of pointless. So it's negative 3 plus or minus 1I is just the same as I root 2. There we go. So that's a pretty tricky question. If you look back at the original problem right here, what are the roots of that? And the answer is that. That's a lot of work, but that's probably why it was one of the most missed questions in the final. Is it the exact same question now? No, we just showed you this answer, but you're going to have something like that. Yes? Half the test you can use calc, half can't. So this kind of a question, well, it could be on either part of the calc, because you really calculated didn't help you on this one, did it? So, you know what I mean? Like, you might have wanted to try to graph it, but if you would have just looked at it, you could have seen pretty quick. We knew the vertex was negative 3 comma 2, that this thing wouldn't graph, that it'd be like a parabola like this. So this could have been on either part of the test. All right. This one's the same exact problem. I don't want to do it again. This time I want to just ask you, what's the vertex? That's a more common question on this. And do you think negative 8 comma 4 would be one of the options? Yes. Don't fall into the trap. You always do counterintuitive on stuff on the inside. So it's positive 8 comma 4. All right, moving on. What's the lowest possible degree? A lot of kids see this one and think, oh, single, double, that makes total of 3, plus another cut through makes 4, degree 4. You're correct. This one on the right is a snaky. If it is a snake, it is worth 3. 3 plus the bounce makes 5, plus the cut through makes 6, degree 6. Why don't we say it's just degree 6? Because there could be what kind of roots that we don't see? Imaginary. So this lowest degree is 6. Just think of it as what's the degree, and the answer is 6. But could it really be a degree 8? Yep, because there could be a unlimited number of imaginaries out there that we can't see. All right, so this could be degree 6, degree 8, degree 10. Remember, imaginaries always come in packages of 2. Could never just add one imaginary root, because the square roots of negatives always have plus and minus in front of them in the quadratic formula, right? So you're going to always have 2 roots. Another way to say it is this. If this is even, because see, both ends are going up, I can only pick even numbers. So if it's going to be 6 or higher, it's going to be 6 or 8 or 10 or 12. Because if the ends were going opposite directions, like now it's going down and the other one's going up, then it could be odd, but it's not. All right. So now, look at this green one. How many roots? Seeing lots of people holding up either a peace symbol or a, yes, this is the way you do it in football. So the 3. If it's easier than to tell how many fingers you're holding up than if you're doing this. I don't know why, I don't know. That's what they do. It's also the OK symbol. Have you ever figured that out? An O with a K, see? Never processed that, huh? Yeah, I was just like, it's actually an O and a K. You want to learn how to do some gang symbols? No, we're not doing that. Okay. You can spell out bloods with your fingers, and then you can get in huge trouble in the wrong neighborhood, and then you'll probably end up dying, and then it'll be my fault. So, okay, this is degree 3. Could it be degree 5? Could it be degree 5? Yes, it could. Because there could be imaginaries we don't see. Could it be degree 6? No, because that's an even number, and this is clearly an odd number because it's going opposite directions on the ends. All right, moving on. Using the rational root theorem, which is, by the way, F con over F co. Factors of the constant over factors of the coefficient. Figure out which of these could be a root. Don't say it. Figure it out. Write it on your screen. I'm going to pause while you do that. All right, so you should be thinking this way. Factors the constant. Factors constant. Factors coefficient. Factors of the constant are 1 and 5. Factors of the coefficient are 2 and 1. And it's plus and minus of the whole schmear. Never heard of schmear before? It's old German saying. Anyway, if you do the top ones divided by the bottom ones, 1 divided by 2 is 1/2. That's an option. 5 divided by 2 is 5/2. That's an option. 1 divided by 1 is 1. That's an option. And the last one is 5 divided by 1, which is 5. And that's an option. And remember, it's plus and minus of the whole schmear. So, plus and minus, plus and minus, plus and minus, plus and minus. So is any one of those on the list? Yes, it is. Right there. Raise your hand if you had it right. Okay, good. All right. One more like that. 10x squared plus 2x minus 1. Figure out for me what the possible roots are. And this time I want you to just list all of them. What are all the possible things? It's not too bad, is it? Because the factors of the constant are so easy. So is there only one possible root? Because the factors of the constant is there's 1. Just 1. Of course, it's always plus and minus. That's the constant. What's the factors of that? 1. That's it? Yes, you're right. And then the factors of the coefficient is actually several. 1 and 2 and 5 and 10. So the right answer is 1 over 1 is the easiest thing. 1. But there are more choices. 1/2 could be a factor. What else could work? 1/5 and 1/10. And plus or minus of the whole schmear. The whole, go ahead, look it up. It's a German, old German saying. All right. While you're at it, look up braggadocious. Some kid last hour actually figured out braggadocious. But anyway, how many imaginary factors does this graph have? And in a little parentheses, which are usually important things, first graph it and find the number of real. All right, I'm going to save you some time. Because I know you can all type on your graphing calculator, and you could hit graph, and it would look like this. So what would that tell you about how many real roots it has? There's 2. Well then, how many imaginary does it have then? 2, because this tells us it should have 4 roots total. 2 of them are imaginary because 2 of them are real. You know, the total has to add up to 4, and there's only 2 here, so the other 2 must be imaginary. You get that? So if you graph it, you'll be able to see how many real roots it has. Then if you know the total, which we do from this right here, then you can figure out how many imaginaries really easy. All right, moving on. This one is a synthetic. Use synthetic to factor this puppy. And some of you might be thinking smartly that I should do divide and conquer on this, but I've tried it. It doesn't work. We'll save the time. Use synthetic. Get going. You can do this. For those of you that are stuck getting started, you go like this. You put some numbers here, etc. They're telling you a -2 does work. But the question is, what is the answer then? Once you've done it, you'll know what the answer is. I'll tell you it works. These are some of the harder questions, which is not too surprising then that it was on our list of top 10 missed questions on the final. Because you can't do divide and conquer on this one because they don't have a common factor. Like, you know how they have to have like x plus 2 and x plus 2? They don't have that, so it won't work. All right, so if -2 really works, I'd use 1 and 5 and 2 and -8. Draw the line, drop it like it's hot. Multiply, add, multiply, add, multiply, add, 0. 1 works too? Cool, but that's going to help us in a minute. Don't use it yet. What matters now is that you know how to interpret this. Okay, so what if synthetic worked? What is the answer? The answer is, what does it factor to? X plus 2 from this, remember that? And then what does that make right there? Well, this is how many x's, and this is how many x squareds. So final answer is x plus 2, and then I don't need that 1 in front there, do I? Just wait. Now, just wait. Do you think I'm done? That's the thing. Because see, because some of you guys kept saying that I tried something else and 1 worked or -1 worked. So both yours and mine, though, need to be factored another level, and then our answers will be the same. Because see, this x plus 2 will still be there. That's a hint that the one you didn't use last time is going to work this time. And the one I didn't use last time is going to work. You tell me, what worked when you did that?
1.
Plain old 1. So I'd have x minus 1 as one of my factors here then, right? Get what I'm saying? I'm factoring this part right here. And x minus 1 and x plus 4. Yay, look at that. Now I bet you when you finished yours, it'll look the same. That's the final answer. All right? So synthetic helps you factor the big, hairy, nasty ones. All right, moving on. What is the domain? Here's the way to think of domain. Domain is all the numbers that go into it, all the x's that will work. Almost everything works. There's usually a few exceptions. In this case, one number, if we put it in here, would crash our function? -1. It's not 0 because the whole bottom has to be 0. So the number we could put in that would make that be 0 is -1. That's why the answer is -1. So you were kind of right when you said 0. You don't want 0 on the bottom. All right. So now, if x is -1, the one thing that won't work is -1. If I put this on a number line, here's -1. I put an empty spot there, and it works over here, and it works over there. Could I say this as all real numbers where x cannot equal -1? Do you get that? All right. Then let's see if you're smart enough to figure out another way to write that. Because the final might have it written a different way. Somebody remembers. You want to give it a shot? Oh, come on, you can do this. What's the smallest number that could possibly work? Negative infinity. All the way up to what number is the first number where it wouldn't work? Negative 1. Union with, what's negative 1 to, there you go. Remember that?
I did not know the union.
U stands for union. It's like the grouping, this and that. It's like the Union of the United States of America. All right. So, I need to talk you through that a little bit farther. Let's say we had another one where there's two things that didn't work. 2 and 5 were both not working, but everything else worked. Do you get how the graph of that would look kind of like this? Everything works except 2 and 5. So how could I write that with this way? All real numbers except x cannot be 2 and x cannot be 5. You write it the other way with the unions and the parentheses. Come on. Write this with parentheses, commas, unions. Smallest number that could possibly work. Good. Up to. Union with 2 to 5. Very good. Union with positive infinity. All right. Get that? Any of those three answers would have been okay. You could have seen it written as a big R with x can't be 2, x can't be 5. You could see it written as a number line with empty spots, or you could see it written with the unions. It all means the same thing. And how about this? What was the original problem? You can do this. And what could be on top? No, because if I did that, there'd be holes. Sure, anything that's not x minus 2 and x minus 5. All right. Why can't you be more like Eric? Eric? All right. So now our smartboard of top 10 questions is done. So now I'm going to talk to you about the stuff that's on your last page of your final packet, and that was on rationals. Now rationals look like this, the kind we just talked about there. If I had you tell me what the vertical, the horizontal asymptotes are, and what the parent, the mother function, so to speak, looks like, could you answer those questions? Can you name the answer for any of those questions? All right, he's confident. Tell me one of those answers. Tell me the question and the answer that you think is right. The vertical asymptotes. You are correct. If x is 4, you'd have a problem, right? And that means the function will never be 4, and that means there's an asymptote there. The asymptotes come from the denominator. So I would recommend you take notes on this one thing, because most kids last hour were really sketchy on this. A lot of them knew there was something to do with Bob, but they had no idea what it was. Okay, yeah, but this one isn't. So, all right, so verticals come from the denominator. Vertical asymptotes come from down here. Do you remember how if there's something that cancels on the top and the bottom, that makes a hole? Is there anything in this problem that would cancel on top and the bottom? So there's no holes. There's only an asymptote. The asymptote's at x equals 4, but there's another asymptote. What kind? Horizontal asymptotes. Horizontal asymptotes, write these things down. Bob, bot, or sob. Bob is an outsider. If there is nothing outside the fraction, like over here, and there's nothing there, then there's really a 0 there. That's y equals 0. If it's bigger on the top, then there's none. There's no horizontal asymptotes. And the last thing is it's same on both. You're looking for an SOB, which are kind of hard to figure out. They'll make you sob, or they're an SOB to figure out. And they're same on both are the ones where it's the same degree on the top and the bottom, like degree 1, degree 1. Some people think the bottom's actually bigger because it's got a 4. Wrong. It's because the degree is 1 and the degree is 1. So they're same on both. This one is the same on both. So if it's same on both, it's a ratio of Oh, you can do this. Yes, it's 1. You're right. Why is it just 1? Because 1 over 1. Very good. So it's 1 over 1, which is 1. So this one is this one. It's not a bob because it's not bigger on the bottom. It's not a bot because it's not bigger on top. It's same on both, and therefore it's y equals 1. So if I were to graph this thing, I'd know to put a line at y equals 1. I'd also know to put a line at x equals 4. And then do you remember the parent function, the mother function? Looks like this. Remember those? All right. So the parent function of this whole thing has a dot there and a dot there, and it gets closer and closer and never touches in both directions like this. And it gets closer and closer and never touches in both directions like that. And then there's asymptotes on the mother function that run right here and right here. Okay, so that's the parent one. So what if they ask you to graph this? Y equals 1 over x minus 4 plus 7. Where should it move? 7 up and right 4. Right. Right 4 up 7. All right. Now, here's a big problem, and how would you start it? Let's say it said x squared plus 2x plus 1 over x plus 1. How would you start? You'd factor, and then you would cancel, and the thing that canceled, yep, and you'd have an x plus 1 and an x plus 1 and an x plus 1 down here, and then this cancels and makes a what? A whole. The whole would be at, the wholes are always a point, like something comma something, and it's negative 1 comma, and then I put the negative 1 back in here, and it would make it 0, negative 1 comma 0. And then is there any horizontal or vertical asymptotes? Well, the horizontals, Bob will tell you the answer. Is it bigger on bottom, bigger on top, same on both? What's the rule for bots? None, so there's no horizontals. The verticals come from the bottom, but there's nothing there anymore because it canceled. If I say that there's a asymptote at negative 1, I'd be wrong because I already know there's a hole there. You know what I mean? Can't be both. A hole looks like this on a graph. Oop, hole. An asymptote looks like this on a graph. There's this line here, and I can get closer and closer, but I can never touch it. I want to touch it, but I can't because it gets so close, but I just can't. Okay. So they're totally different things. One's a hole, just a gap, and the other one's this line you can never touch. All right. I think we've talked about rationals enough, so that's the last page of your packet. Your assignment is to finish the packet. Have it done so that when I flip through it, while you're taking the final, I can say a little plus by your name, like, hey, this kid gets a break as long as their other homework looks good. Doesn't mean you have to have every single assignment. If you have one missing assignment, I'll give you a break because I know life gets busy. Couple missing assignments, I'd figure that kid really should have turned it in because he can still turn it in. Like you can turn it in up until Wednesday. That would be tomorrow. You know, turn in late work, get it done by tomorrow. Yes. All right.